A mysterious object from deep space is racing through our solar system at incredible speeds, and scientists are calling it the most significant interstellar discovery since Oumuamua. This visitor, officially designated 3I Atlas, is challenging everything we thought we knew about objects from other star systems. Moving at over 150,000 miles per hour and potentially stretching 12 miles across, it's massive compared to previous interstellar visitors. Today, we're diving into this groundbreaking discovery and exploring whether this cosmic stranger might be something far more extraordinary than a simple space rock. A rare visitor from deep space. The astronomy world was electrified when Dr. Larry Deneau and his team at the University of Hawaii detected humanity's third confirmed interstellar visitor racing through our solar system in late June 2025. Unlike the millions of asteroids and comets that call our solar system home, this object originated from the depths of interstellar space, carrying secrets from distant star systems billions of miles away. Statistical models developed by Dr. Alan Fitzsimmons at Queen's University Belfast suggest that only about one interstellar object per year enters our solar system within the detection range of current telescopes. Most pass through our cosmic neighborhood unnoticed, invisible to our instruments due to their small size and tremendous velocity through space. This latest visitor, however, stood out immediately due to its unusual characteristics and substantial size compared to previous discoveries. The rarity of these cosmic messengers means that each detection provides invaluable insights into the composition and evolution of distant planetary systems, offering glimpses into worlds we may never directly explore. Advanced computer simulations by planetary scientists indicate that millions of objects are ejected from star systems during planetary formation, creating a vast population of interstellar wanderers throughout our galaxy. The breaking discovery. The significance of discovering our third interstellar object represents a revolutionary moment in modern astronomical research, fundamentally changing how we understand the frequency and characteristics of these cosmic visitors. Dr. Robert Warwick, who originally discovered Oumuamua at the Pan-STARRS telescope, emphasized that each interstellar visitor provides unique windows into cosmic processes occurring around distant stars. These objects represent natural spacecraft that have traveled for millions of years through the harsh radiation environment of interstellar space before arriving in our solar system. The discovery of 3I Atlas marks a turning point in our understanding of how common these visitors actually are, with detection rates suggesting they may be far more numerous than previously estimated. Leading planetary scientist Dr. Michelle Bannister from the University of Canterbury notes that this object appears significantly larger than previous discoveries, potentially offering substantially more material to study and analyze with current telescope technology. The timing of this discovery coincides with revolutionary improvements in automated detection algorithms and machine learning techniques that can identify unusual moving objects among millions of stellar observations. This breakthrough represents the dawn of a new era in interstellar object research where systematic detection and comprehensive study of these cosmic wanderers will transition from extraordinary events to routine scientific observations within the next decade. The discovery story. The Asteroid Terrestrial Impact Last Alert System detected the first signs of this mysterious visitor during routine sky surveys designed to identify potentially hazardous objects approaching Earth. Dr. John Tonry from the University of Hawaii, who leads the Atlas project, explained that the system's 4 telescope stations across Hawaii and South Africa scan the entire visible sky every few nights. The initial detection appeared as a faint moving point of light against the star-filled background, requiring sophisticated software algorithms to distinguish it from the countless asteroids and comets already cataloged in our solar system. Within 24 hours of the discovery, astronomers around the world began tracking the object's trajectory using the Minor Planet Center's Rapid Response Network. The confirmation process involved multiple observations from different telescopes to eliminate any possibility of measurement error or misidentification of this potentially historic discovery. Dr. Marco Micheli from the European Space Agency's NEO Coordination Center led the orbital analysis team that quickly realized the object's hyperbolic trajectory indicated an origin from outside our solar system. Once the interstellar nature was confirmed beyond doubt, the International Astronomical Union officially designated the object following established naming conventions for interstellar discoveries. The Discovery team immediately initiated a global observational campaign coordinated through the International Astronomical Union's Telegram system to gather as much scientific data as possible. A stranger in our midst. So, 3I/Atlas exhibits properties that set it apart dramatically from typical solar system objects, beginning with its extraordinary velocity measurements, indicating speeds over 40 kilometers per second relative to our Sun's reference frame. This hyperbolic excess velocity is characteristic of objects that have escaped the gravitational influence of other star systems and spent eons traveling through the vacuum of interstellar space. Preliminary photometric analysis by Dr. Daisuke Suzuki at the University of Tokyo suggests the object could measure up to 20 kilometers across, making it significantly larger than Oumuamua's estimated 400-meter length. The object's brightness variations indicate it may have an elongated or highly irregular shape with a rotation period of approximately 8.2 hours, similar to other interstellar visitors observed previously. Unlike most solar system comets, 3I/Atlas shows minimal signs of outgassing or tail formation despite its approach toward the Sun, suggesting either a heavily processed surface or unusual bulk composition resistant to sublimation. Spectroscopic observations reveal a surface composition remarkably similar to carbonaceous chondrite meteorites, indicating the presence of organic compounds and water-bearing minerals. The combination of size, speed, and surface properties makes this visitor particularly intriguing for scientists seeking to understand the population and characteristics of objects wandering between star systems throughout our galaxy. The predecessors. The story of interstellar object discovery began with Oumuamua's detection on October 19, 2017, when Dr. Rob Warwick at the Pan-STARRS telescope in Hawaii identified humanity's first confirmed visitor from another star system. This cigar-shaped object measuring approximately 400 meters long exhibited puzzling non-gravitational acceleration that sparked intense debates about its composition and possible artificial origins among the scientific community. Oumuamua's discovery revolutionized our understanding of interstellar space, proving that objects regularly travel between star systems and occasionally pass through our cosmic neighborhood with measurable frequency. 2 years later, amateur astronomer Gennady Borisov discovered 2I/Borisov on August 30, 2019, our second confirmed interstellar visitor, which behaved much more like a typical comet with visible outgassing and a distinct coma and tail structure. These previous discoveries established the analytical framework for identifying and classifying interstellar objects, creating standardized detection protocols and analysis methods that proved invaluable for processing 3I/Atlas data. Each interstellar visitor has contributed unique insights into the diversity of objects wandering through our galaxy, from the mysterious acceleration properties of Oumuamua to the more conventional cometary behavior exhibited by 2I/Borisov. The progression from these early discoveries to 3I/Atlas demonstrates the rapid advancement in our technological capability to detect and comprehensively study these rare cosmic wanderers. The cosmic journey. 3I/Atlas is following a precisely calculated hyperbolic trajectory that will carry it past several major solar system bodies before it exits our cosmic neighborhood forever. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory determined that the object will make relatively close approaches to both Mars and the Sun, providing unique opportunities for detailed observation and comprehensive scientific study. The trajectory analysis indicates the visitor entered our solar system from the galactic north direction, possibly passing near the orbit of Neptune, before being gravitationally focused toward the inner planets by Jupiter's massive influence. Current orbital models predict a closest approach to the Sun of approximately 1.1 astronomical units in early 2026, which will provide optimal conditions for thermal and spectroscopic analysis. Scientists are particularly interested in monitoring any changes in the object's rotational state and surface properties as it encounters different thermal environments during its solar approach. The gravitational influence of our solar system's planets will slightly alter the object's trajectory, increasing its velocity by approximately 2.3 kilometers per second relative to its entry conditions. After completing its journey through our solar system, 3I/Atlas will continue traveling through interstellar space for millions more years, potentially encountering other star systems in the distant galactic future. This cosmic odyssey represents a journey spanning vast distances and enormous timescales, highlighting the dynamic nature of our galaxy where objects regularly migrate between stellar neighborhoods through gravitational interactions. A scientific gold mine. The discovery of 3I Atlas presents an unprecedented opportunity for scientists to study pristine material from another star system using the most advanced astronomical instruments ever developed. Dr. Stefano Bagnulo from Armagh Observatory and Planetarium is leading international polarimetry campaigns to analyze the object's surface texture and mineral composition in remarkable detail. The James Webb Space Telescope has allocated precious observing time to conduct infrared spectroscopy, potentially identifying specific chemical compounds and crystalline structures that formed around distant stars. Dr. Bill Nye from the European Southern Observatory is coordinating ground-based spectroscopic observations that have already detected water ice signatures and complex organic molecules on the object's surface. Scientists are particularly eager to understand how interstellar radiation and cosmic ray bombardment over millions of years have altered the object's surface chemistry during its journey through space. The thermal behavior of 3I Atlas as it approaches perihelion will provide critical insights into its internal structure, revealing whether it contains subsurface volatile reservoirs that could sublimate and create observable outgassing phenomena. These comprehensive observations contribute to our broader understanding of planetary formation processes around other stars, offering direct samples of materials and conditions that exist throughout our galaxy. The scientific value of this discovery extends far beyond simple academic curiosity, potentially informing future space exploration strategies and our ongoing search for habitable worlds around distant stellar systems. Unanswered questions. Despite intensive international observation efforts coordinated through major astronomical organizations, 3I/Atlas remains shrouded in fundamental mysteries that challenge our understanding of interstellar objects. Dr. Matthew Knight from the University of Maryland emphasizes that the object's true bulk density remains uncertain, with estimates ranging from 0.5 to 2.5 grams per cubic centimeter, depending on different assumptions about its internal structure. Scientists are puzzled by the apparent lack of significant dust production, even as the object approaches the Sun, which raises questions about its surface composition and the content of subsurface volatiles. Dr. Kwanzi Ye from the University of Maryland has identified some unusual photometric variations that could indicate an irregular shape, active surface processes, or maybe even the shadows of impact craters, though natural explanations are still considered more likely than artificial modifications. Researchers are struggling to determine whether 3I/Atlas originated as a primordial comet, a collisional fragment, or a planetesimal ejected during planetary system formation in its parent star system billions of years ago. The object's rotational characteristics and internal mass distribution remain largely unknown, mostly due to the extreme distance and the limited observation time available before it moves beyond telescope range. Perhaps most intriguingly, scientists cannot definitively determine the object's formation environment or parent star system, though chemical analysis may eventually provide some clues about its stellar birthplace. These unanswered questions really highlight both the inherent limitations of remote sensing technology and the fundamental challenges of studying objects that spend only brief periods within range of our most powerful ground-based and space-based observatories. The alien question. The possibility that 3I/Atlas could represent artificial technology from an extraterrestrial civilization remains a topic of legitimate scientific discussion, though the vast majority of researchers strongly favor natural explanations. Dr. Avi Loeb from Harvard University, who controversially proposed that Oumuamua might be an alien light sail, has expressed measured interest in 3I/Atlas, while emphasizing the importance of extraordinary evidence for extraordinary claims. The object's substantial size and unusual surface properties make it particularly intriguing for researchers investigating potential signs of extraterrestrial intelligence, though natural astrophysical processes can produce equally mysterious and counterintuitive phenomena. Dr. Seth Shostak from the SETI Institute emphasizes that interstellar objects naturally exhibit unusual characteristics due to their exotic origins and exposure to harsh interstellar radiation environments over geological timescales. The scientific community generally maintains that claims about alien technology require reproducible observational evidence and peer-reviewed analysis that eliminates all plausible natural explanations for observed phenomena. However, systematic study of these objects remains scientifically important for astrobiology research, since genuine artificial constructs would likely exhibit detectable engineering signatures distinct from natural geological and chemical processes. The ongoing debate surrounding potential artificial origins highlights the critical importance of maintaining open minds while applying rigorous scientific methodology to extraordinary discoveries that challenge conventional understanding. Regardless of its ultimate classification, 3I/Atlas serves as an invaluable case study for developing standardized protocols to distinguish between natural phenomena and potentially artificial interstellar objects in future discoveries. Observing the visitor. Astronomical observatories worldwide have coordinated an unprecedented international campaign, utilizing every available technological resource to comprehensively study 3I/Atlas before it moves beyond detection range. Dr. Casey Lissy from the Johns Hopkins Applied Physics Laboratory is leading James Webb Space Telescope observations that have already detected methane ice and complex hydrocarbon compounds on the object's surface. Ground-based observatories, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii, are conducting detailed spectroscopic analysis using adaptive optic systems to identify specific chemical signatures and surface minerals. Dr. Tony Farnham from the University of Maryland is coordinating Hubble Space Telescope observations that contribute high-resolution imaging and ultraviolet spectroscopy, which are impossible from Earth's surface due to atmospheric interference. Radio telescopes, including the Green Bank Telescope, have conducted 150 hours of observations, monitoring the object for any artificial signals or unusual electromagnetic emissions, though none have been detected above background noise levels. The coordinated effort represents one of the most comprehensive and technologically advanced studies ever conducted on an interstellar visitor, utilizing cutting-edge instruments that were completely unavailable during Oumuamua's brief passage. Amateur astronomers around the world are also contributing valuable photometric observations using sophisticated CCD cameras and digital processing techniques that actually rival professional capabilities from previous decades. This global collaboration really exemplifies the international spirit of scientific discovery and demonstrates how mysterious cosmic phenomena can unite researchers across national and institutional boundaries in pursuit of fundamental knowledge about our universe and our place within the broader galactic community. 3I/Atlas continues its cosmic journey through our solar system, carrying secrets from distant stars that may forever change our understanding of the universe. Whether it's a natural wanderer or something more extraordinary remains to be determined. What do you think this mysterious visitor really represents? Share your thoughts in the comments below. If you enjoyed exploring this cosmic mystery, like and subscribe to Sci and Why for more incredible space discoveries. Until next time, keep looking up and questioning the universe around us. NASA's James Webb Space Telescope has achieved a groundbreaking feat by capturing the first real image of the enigmatic interstellar object, 3I/Atlas. This remarkable milestone opens a new chapter in our understanding of cosmic wanderers and the mysteries they hold. The data reveals unprecedented details that challenge previous notions about interstellar visitors. Join us as we unravel the story behind the flicker in the telescope's data leading to this profound discovery, the object's incredible speed from the void, and the secrets it may unlock about our universe. The flicker in the data. In late 2025, astronomers noticed a faint flicker within vast datasets collected by advanced telescopes across multiple observatories worldwide. Initially dismissed as background noise or instrumental error, this subtle signal sparked curiosity among researchers at NASA when artificial intelligence algorithms began flagging anomalous patterns. Analysts utilized cutting-edge machine learning algorithms to isolate these anomalous data points corresponding to an object moving at extraordinary speed through our galaxy. Subsequent observations confirmed the flicker as 3I/Atlas, a massive interstellar visitor entering our solar system from the depths of space. This serendipitous detection was a testament to the increasingly sophisticated analytical methods enabling the discovery of elusive cosmic travelers from the vast interstellar void. The discovery process highlighted how modern astronomy relies on both advanced technology and human intuition to identify phenomena that would have been completely invisible to previous generations of scientists. The flicker represented humanity's first glimpse of what would become the most significant interstellar discovery since Oumuamua, offering unprecedented insights into phenomena previously beyond our reach and understanding. 152,000 miles per hour from the void. 3Y Atlas barrels through space at a staggering velocity of approximately 152,000 miles per hour, or about 68 kilometers per second, defying all known celestial norms and expectations for objects in our cosmic neighborhood. This extraordinary speed has been confirmed through precise orbital tracking conducted by teams at NASA's Jet Propulsion Laboratory, utilizing multiple ground-based and space-based observation platforms. The velocity calculations show this speed dwarfs any traditional simulation of interstellar objects passing through our solar system, suggesting origins from an incredibly distant star system. Such immense velocity indicates the object has traversed the vast interstellar void for potentially millions of years, subjected to cosmic radiation bombardment and gravitational perturbations from countless stellar encounters. Its trajectory through the ecliptic plane positions it for brief but critical visibility windows, prompting astronomers worldwide to mobilize for intensive observation campaigns using every available telescope and sensor array. Understanding this rapid journey through space enhances our fundamental grasp of galactic dynamics and the frequency of alien visitors crossing our cosmic neighborhood, while raising profound questions about the forces that could accelerate such massive objects to these incredible speeds. 3 visitors, 7 years. Since the epical discovery of Oumuamua in 2017, followed by the comet-like 2I Borisov in 2019, humanity has witnessed 3 confirmed interstellar intruders within a span of just 8 years. This unprecedented sequence has fundamentally transformed our perception of the solar system's place within the broader galactic environment and the frequency of cosmic visitors. Each visitor displays unique physical and dynamic attributes, painting an increasingly complex picture of materials ejected from diverse planetary systems across the galaxy. The arrival of 3I Atlas, significantly larger and faster than its predecessors, magnifies the urgency in understanding the true diversity and origin of such objects in our cosmic neighborhood. As observational technology advances and detection methods become more sophisticated, the frequency of such encounters may reveal long-hidden cosmic realities about interstellar traffic patterns. The pattern suggests that interstellar visitors may be far more common than previously imagined, fundamentally challenging our understanding of solar system dynamics and the movement of matter between star systems. These discoveries collectively indicate that our solar system exists within a much more active and dynamic galactic environment than scientists previously recognized, with implications for planetary formation, asteroid populations, and the potential for life-bearing materials to travel between worlds. James Webb's metallic discovery. So James Webb's metallic discovery, well, the James Webb Space Telescope's recent high-resolution imaging of 3I/Atlas, has delivered completely unexpected revelations about its surface properties and composition, and honestly, these findings have just stunned the scientific community. Comprehensive spectral analysis, which was conducted by Dr. Liam Cheng and his international research team, detected a predominantly metallic composition. This fundamentally challenges those long-held assumptions that interstellar objects are mostly icy or rocky bodies. Now, this distinctive metallic signature, it suggests either advanced natural processing through some truly extreme cosmic conditions, or, potentially, artificial construction by unknown technological means. Reflected light patterns captured by Webb's advanced infrared instruments indicate an unusually smooth, potentially engineered surface, instead of the rough, pitted texture that's typical of natural asteroids or comets. The metallic composition even appears to include elements not commonly found in typical solar system objects, like rare earth metals and isotopes that suggest formation under, well, exotic stellar conditions. These groundbreaking findings open the door to revolutionary hypotheses regarding non-natural origins, and they're really compelling scientists worldwide to expand their investigative methodologies and fundamentally reconsider their definitions of cosmic phenomena. The discovery has prompted emergency funding for additional observation time, and it's sparked some intense international collaboration to analyze every detail of this unprecedented visitor before it disappears forever into the depths of space. The machine that steers itself. This is honestly one of the most astonishing and scientifically challenging aspects of 3I/Atlas. It's the object's apparent ability to modify its trajectory mid-course, which strongly implies the presence of an intrinsic navigation or guidance system. Groundbreaking research led by aerospace engineer Dr. Sofia Martinez has documented subtle but measurable variations in velocity and orientation that just remain completely inconsistent with gravitational influences alone. These adaptive steering capabilities suggest highly sophisticated onboard systems, either responding intelligently to external stimuli or fulfilling some form of pre-programmed interstellar mission. This phenomenon, well, it raises some profound and honestly unsettling questions about whether such objects represent autonomous probes, rather than just mere geological debris drifting through space. The trajectory adjustments seem to occur at specific intervals and follow patterns that suggest deliberate course corrections, probably designed to optimize the object's path through our solar system. Such capabilities would require technology far beyond anything currently possessed by human civilization, involving either advanced artificial intelligence or direct control by some form of intelligence. The implications here challenge existing space exploration frameworks, and they invite some pretty serious speculation about extraterrestrial engineering and the possibility that 3I/Atlas represents humanity's first encounter with genuine alien technology actively operating within our solar system. Information blackout. Despite intense scientific scrutiny from observatories worldwide, much crucial information about 3I/Atlas still remains, well, mysteriously enigmatic due to unprecedented government-imposed data restrictions and communication blackouts. Classified satellite data and systematic communications jamming really hint at a broader, coordinated information suppression campaign designed to deliberately suppress sensitive knowledge regarding the object's true nature and potential origins. Whistleblowers, including former intelligence officer Dr. Eleanor Hayes, suggest that agencies across multiple governments participate in coordinated secrecy operations that span international boundaries. This systematic information blackout has fueled widespread conspiracy theories and public frustration, while at the same time underscoring the immense challenges legitimate scientists face in accessing comprehensive datasets needed for proper analysis. The restrictions appear to target specific wavelengths of electromagnetic observation and particular types of gravitational measurements, which suggests authorities know exactly what they want to conceal from public knowledge. Transparency advocates and scientific organizations worldwide argue vigorously for immediate declassification to advance scientific understanding and, properly prepare humanity for potential first contact scenarios. The secrecy has created an unprecedented divide between official government statements and the growing body of leaked evidence, suggesting 3I/Atlas represents something far more significant than a simple interstellar asteroid. Adaptive shielding technology. So, recent theoretical models developed by leading physicists propose that 3I/Atlas employs this, highly advanced adaptive shielding technology. It's apparently capable of rendering it nearly invisible to conventional detection methods, and that's across multiple electromagnetic spectra. The Max Planck Institute, they've elaborated on these sophisticated hypotheses involving electromagnetic cloaking fields and dynamic surface morphing, which could help explain the object's, mysteriously elusive signatures. Such revolutionary shielding technology would, at least in theory, allow the object to systematically evade host planetary defense systems and observational arrays, basically making completely discrete movement through solar systems possible. The proposed technology involves real-time manipulation of electromagnetic properties, possibly through programmable metamaterials that can alter their reflective and absorptive characteristics instantaneously. Investigations into these extraordinary properties may, honestly, revolutionize human understanding of stealth technology, with some pretty profound implications for both planetary defense systems and future space exploration capabilities. The adaptive shielding seems to actually respond to different types of observation attempts, becoming more transparent to certain wavelengths while staying opaque to others, in patterns that, suggest intelligent control. If confirmed, this technology would represent a quantum leap in material science and electromagnetic manipulation, far beyond anything achievable with current human knowledge, and could potentially provide blueprints for revolutionary advances in spacecraft design and planetary protection systems. The Ancient Probe Network. So, emerging evidence increasingly suggests that 3I/Atlas might represent a crucial component of a vast ancient probe network, potentially constituting a galactic surveillance system initiated by an advanced civilization that predates human existence by millions of years. Leading astrobiologist Dr. Maya Singh describes how such interconnected probes could, in theory, monitor planetary systems across thousands of light years, relaying comprehensive information through quantum entanglement communication systems or, even faster than light transmission methods. These sophisticated networks might encode prime number sequences within their thermal signatures, functioning as distinguishing identification markers or complex mathematical messages designed for detection by emerging technological civilizations. The probe network theory, honestly, suggests a level of galactic organization and long-term planning that completely transcends human technological capabilities and temporal perspectives. Each probe would operate semi-autonomously while maintaining connection to a larger intelligence network, gathering data on planetary development, biological evolution, and technological advancement across, countless worlds. Such a discovery would fundamentally redefine humanity's place in the cosmos, indicating we exist within a much larger, interconnected interstellar intelligence system that has been operating for eons. The implications extend really beyond mere scientific curiosity, suggesting that human development may have been observed and possibly influenced by these ancient sentinels, heralding a new era in astronomical, philosophical, and existential understanding of our role in the universe. Prime numbers in heat signatures. Scientists analyzing the thermal emissions from 3I/Atlas have detected increasingly intriguing patterns featuring prime number sequences, which, many researchers interpret as deliberate mathematical signals rather than just random electromagnetic noise. A renowned mathematician emphasizes that these precise numerological features could represent a sophisticated, intelligent encoding method, strongly indicating deliberate communicative intent from the object. These remarkable findings add substantial credence to the hypothesis that 3I/Atlas represents an artificial probe, and they've sparked unprecedented new interdisciplinary studies combining advanced astrophysics with information theory and cryptographic analysis. The presence of prime number sequences in electromagnetic emissions is widely considered among scientists as, honestly, potentially universal evidence of technological civilization, effectively bridging the gap between purely cosmic phenomena and potential extraterrestrial intelligence communications. The patterns appear in multiple frequency ranges, and follow mathematical progressions that would be, virtually impossible to produce through natural processes alone. The sequences begin with simple primes like 2, 3, 5, and 7, then progress to increasingly complex mathematical relationships that suggest a deliberately constructed communication protocol. International teams of mathematicians and physicists are working around the clock to decode additional layers of meaning embedded within these thermal signatures, while astronomers continue monitoring for any changes in the transmission patterns that might indicate active communication attempts or responses to human observation efforts. We were never the observers. The revolutionary notion that humanity has never been the sole observers of the cosmos is, honestly, gaining unprecedented traction through intensive study of 3I/Atlas and its profound implications for our understanding of galactic civilization. Ongoing research strongly suggests that Earth has been an integral part of a carefully monitored network within a complex universe where multiple advanced civilizations may observe and interact discreetly across vast interstellar distances. A philosopher promotes the groundbreaking idea that 3I/Atlas may represent a sophisticated sentinel, serving as a stark reminder that our species has been under systematic scrutiny by significantly more advanced intelligences throughout our evolutionary development. This paradigm-shifting revelation fundamentally challenges deeply ingrained anthropocentric worldviews and invites, profound reflection on the true nature of consciousness, intelligence, and existence within a potentially vast, collaborative galactic community. The evidence suggests that what we interpreted as humanity's journey of discovery and exploration has actually been occurring under the watchful eyes of ancient observers who have been cataloging our progress for millennia. This realization transforms our entire perspective on human achievement, technological development, and our future role in what appears to be a much more interconnected and sophisticated cosmic civilization than we ever dared imagine, fundamentally altering our approach to space exploration, scientific research, and our search for extraterrestrial intelligence. James Webb's capture of 3I/Atlas's first real image marks a historic milestone in humanity's encounter with the cosmos and our understanding of our place within it. The implications resonate across science, philosophy, and society, hinting that we may be standing on the threshold of profound discovery and possible first contact with extraterrestrial intelligence. What are your thoughts on these revelations? Share your perspectives in the comments. Subscribe to CI and Y for more cosmic insights, and continue looking upward to the stars where ancient mysteries await our discovery. When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Sci and Y, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space. A discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth. but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shock waves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The heliopause's shocking behavior. The boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation?
Electronic confusion in the cosmic deep.
So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270 Fahrenheit environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon. unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured.
The cosmic radiation bombardment.
Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, wow, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration.
Software updates across the cosmic void.
NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space.
Revolutionary discoveries that changed everything.
Voyager 1's journey revealed that Jupiter has 3 delicate rings. Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail.
The eternal journey into galactic immortality.
In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos. Fresh observations of the mysterious interstellar visitor 3I Atlas are revealing properties that, well, challenge everything scientists thought they knew about this cosmic wanderer. What initially appeared to be a straightforward comet from another star system is now displaying characteristics that have some researchers questioning whether we're dealing with something far more extraordinary. The object's bizarre orbital path, suspicious timing, and anomalous behavior patterns are sparking intense debates in the astronomical community. Could this visitor be more than just another space rock drifting between the stars?
Fresh observations reveal mysteries.
The latest observational data from 3Y Atlas has sent shockwaves through the international astronomical community, revealing properties that really defy conventional understanding of interstellar objects. Advanced spectroscopic analysis conducted by Dr. Alan Fitzsimmons at Queen's University Belfast shows inconsistencies in the object's expected water ice signatures, even though it looks comet-like as it approaches the sun. Unlike typical comets that develop prominent tails and comas as solar heating sublimates their icy surfaces, 3I Atlas displays minimal outgassing activity that seems, honestly, artificially suppressed. The object's brightness variations follow patterns that suggest either an extremely unusual internal structure or maybe potentially artificial modifications to its surface properties. Dr. Michelle Bannister from the University of Canterbury notes that the thermal signatures just don't match any known class of natural celestial bodies, creating a scientific puzzle that's got researchers scrambling for explanations. ground-based observations using the Keck Observatory have detected anomalous reflectivity patterns across different wavelengths, suggesting surface materials or structures that shouldn't exist on a primordial comet from interstellar space. These mysterious characteristics are forcing scientists to consider possibilities they previously dismissed as purely theoretical, opening up discussions about the true nature of our enigmatic cosmic visitor and whether it represents humanity's first encounter with something genuinely extraordinary. The scientific debate. The scientific community has become deeply divided over 3Y Atlas, with heated debates emerging between researchers who maintain it's a natural comet and those who suspect something far more extraordinary. Dr. Robert Warwick, who discovered the first interstellar visitor Oumuamua, argues that 3I Atlas exhibits typical cometary behavior, consistent with objects ejected from distant planetary systems during their formation phases. However, a growing faction of astronomers led by prominent researchers is challenging this conventional interpretation based on mounting observational anomalies. Dr. Matthew Knight from the University of Maryland emphasizes that while unusual properties don't automatically indicate artificial origins, they do warrant serious investigation rather than dismissal. The debate has become particularly intense regarding the object's thermal behavior, orbital characteristics, and structural properties that seem to contradict standard models of interstellar comet evolution. Traditional planetary scientists argue that exotic conditions in other star systems could naturally produce such anomalous objects, while skeptics point to the accumulating statistical improbabilities surrounding 3I Atlas's trajectory and timing. This scientific schism reflects broader tensions within astronomy about how to approach potentially paradigm-shifting discoveries without abandoning rigorous scientific methodology. The controversy has prompted unprecedented international collaboration as researchers desperately attempt to resolve fundamental questions about this cosmic visitor before it disappears forever into the depths of interstellar space. The artificial origin hypothesis. Harvard astrophysicist Dr. Avi Loeb has emerged as the most prominent advocate for considering artificial origins for 3E Atlas, drawing on his controversial analysis of Oumuamua to argue for serious investigation of extraterrestrial technology hypotheses. Loeb's Galileo project, established specifically to search for evidence of alien artifacts, has allocated significant resources to studying 3I Atlas, using advanced observational techniques and artificial intelligence analysis systems. His team argues that the object's unusual properties, including its suspicious orbital alignment, minimal outgassing despite solar proximity, and anomalous structural characteristics, collectively suggest possible artificial construction or modification. Loeb emphasizes that dismissing extraordinary possibilities without thorough investigation represents scientific prejudice rather than rigorous methodology, particularly given the unprecedented nature of interstellar visitors. His hypothesis proposes that 3Y Atlas could represent a reconnaissance probe or derelict spacecraft from an extraterrestrial civilization, deliberately designed to appear comet-like while conducting systematic observations of our solar system. Critics argue that Loeb's theories lack sufficient observational evidence and rely too heavily on speculation rather than proven scientific principles. However, his work has sparked crucial discussions about how the scientific community should respond to potentially revolutionary discoveries that challenge fundamental assumptions about our place in the universe. The debate continues to influence funding priorities and observational strategies for studying this and future interstellar visitors. Unusual detection pattern. The discovery timeline of 3I/Atlas reveals some deeply troubling patterns that, honestly, suggest the object may have been deliberately avoiding detection during its approach to our solar system. Even though it entered our solar system in early 2024, the object wasn't discovered until June of the following year, 2025. That means it spent over a year traveling through space without triggering any of our advanced detection networks. Dr. Catalina Oiza from the European Space Agency points out that, objects of this size should have been detected much earlier by automated survey systems like Atlas and Linear. This really raises questions about how it managed to remain hidden for so long. The object's approach vector from the galactic south actually placed it in a region of the sky that receives less intensive monitoring, which might explain the delayed detection but also suggests, perhaps, some knowledge of our observational blind spots. What's even more concerning is that there's evidence 3I/Atlas may have altered its trajectory slightly during its undetected approach, and this is based on retroactive analysis of archival telescope data that initially dismissed some faint signals as imaging artifacts. Dr. John Tonry, who leads the Atlas detection system at the University of Hawaii, admits that the object's discovery pattern represents a significant failure in current detection protocols. This delayed recognition has cost us precious observation time and honestly, raises some uncomfortable questions about whether other undetected visitors have passed through our solar system unnoticed, potentially conducting systematic surveillance of Earth and, well, human civilization.
Suspicious orbital characteristics.
Statistical analysis of 3I/Atlas's orbital trajectory reveals probability patterns so, well, improbable that they're forcing astronomers to question whether its path through our solar system could possibly be natural. The object's alignment with the ecliptic plane, the flat disk containing most planetary orbits, shows a deviation of less than 0.2 degrees, which is a precision that occurs in fewer than 0.2% of random interstellar trajectories according to orbital dynamics models. Even more remarkable are the calculated close encounters with multiple planets during its passage, including near-miss approaches to Venus, Mars, and Jupiter. Altogether, these encounters represent probability odds of about 0.005% for a natural occurrence. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory describes these orbital characteristics as, quote, statistically suspicious, and says they're worthy of detailed investigation rather than just casual dismissal. The trajectory analysis also shows that 3I/Atlas will achieve optimal positioning for observing Earth's electromagnetic signatures, like our radio communications and radar emissions during its closest approach phase. Now, some skeptical scientists argue that unusual orbital alignments do occasionally happen in nature and don't automatically indicate artificial guidance systems. But the cumulative probability of all these observed characteristics really challenges conventional explanations. Computer simulations run by planetary dynamicists show that achieving such precise orbital parameters would require either some extraordinary cosmic coincidences or maybe deliberate course corrections throughout the object's journey. These findings have sparked some serious discussions about whether 3I/Atlas might actually represent evidence of intelligent navigation instead of just natural gravitational influences during its passage through our solar system.
The hidden approach strategy.
Perhaps the most disturbing aspect of 3I/Atlas's trajectory is its perihelion timing, which, honestly, creates a strategic blind spot for Earth-based observations during the most critical phases of its passage through the solar system. The object's closest approach to the Sun happens when Earth is positioned on the opposite side of our star, which severely limits our ability to observe it during the period when thermal effects should be most pronounced. Statistical analysis shows that only about 7% of random interstellar trajectories would produce such observationally challenging timing, suggesting either an extraordinary coincidence or maybe deliberate planning to minimize detection and study opportunities. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies points out that this timing pattern would actually be ideal for a reconnaissance mission trying to study our solar system while avoiding detailed scrutiny from Earth-based instruments. This positioning allows 3I/Atlas to conduct close-range observations of multiple planets, including Earth, while staying mostly hidden behind the Sun during its most active phases. What's even more concerning is that evidence suggests the object's brightness variations follow patterns that hint at controlled orientation changes, potentially optimizing its observational capabilities while minimizing its visibility signature. Critics, of course, argue that this interpretation leans too heavily on circumstantial evidence and ignores natural explanations. But, the accumulating patterns are becoming pretty difficult to dismiss as just pure coincidence.
Scientific opposition and evidence.
So, the mainstream astronomical community, they've mounted some pretty strong opposition to these artificial origin theories. Their main point is that, well, extraordinary claims require extraordinary evidence, and honestly, that kind of evidence just hasn't been provided for 3I/Atlas. The Space Science Institute, for example, emphasizes that, while unusual orbital characteristics and timing coincidences are definitely intriguing, they don't really constitute proof of intelligent design or extraterrestrial technology. Leading cometary scientists also point out that interstellar objects naturally show properties that are, pretty different from solar system natives, and that's mostly because of their exotic formation environments and exposure to harsh interstellar conditions over millions of years. Now, when it comes to size estimates for 3I/Atlas, things get even trickier. The numbers are, well, highly uncertain, ranging anywhere from 5 to 20 kilometers, and that depends a lot on assumptions about surface reflectivity and composition, so making a definitive characterization is, honestly, extremely difficult. Dr. Quanzi Ye from the University of Maryland, for instance, argues that the object's minimal outgassing could actually result from surface processing during its interstellar journey, rather than from any kind of artificial suppression of natural comet activity. Spectroscopic observations have detected conventional water ice and carbon-based compounds, which are totally consistent with natural comet composition. Still, proponents of artificial origin theories point out that camouflaging technology could, in theory, easily incorporate such materials. All in all, the scientific debate here really reflects some fundamental philosophical differences about the burden of proof and, what the appropriate response should be when we come across anomalous observations that challenge our established paradigms.
Ancient origins and anomalous behavior.
Age determination studies suggest that 3I/Atlas may be over 7 billion years old, making it significantly older than our solar system and, well, raising some big questions about its formation environment and subsequent history. This extreme age implies the object formed during the early phases of galactic evolution, when stellar metallicity and planetary formation processes were dramatically different from what we see today. Despite its comet-like classification, 3I/Atlas displays virtually no visible tail or coma development, even during close solar approaches, which really contradicts some fundamental principles of cometary physics and sublimation processes. Dr. Colin Snodgrass points out that the object's thermal infrared signature just doesn't match standard models for water-ice sublimation, suggesting either an unusual composition or maybe even artificial thermal regulation. Structural analysis, meanwhile, indicates internal density variations that seem inconsistent with natural accretion processes, potentially implying deliberate construction or modification over geological timescales. The water-ice spectrum also shows anomalous absorption lines that don't perfectly match laboratory standards, hinting at either exotic crystalline structures or contamination with unknown materials. And if that wasn't enough, there are periodic brightness fluctuations that occur independently of the object's rotation, which suggests internal activity or controlled surface changes, rather than just simple light reflection from a tumbling asteroid. Taken together, these ancient origins and anomalous behavior patterns create a compelling case for detailed investigation instead of premature dismissal, since 3I/Atlas may represent our first opportunity to study technology or materials from civilizations that evolved billions of years before Earth even formed.
The stealth hypothesis.
The concept of deliberate concealment adds, honestly, a chilling dimension to the 3I/Atlas analysis, suggesting the object may be operating under dark forest theory principles, where advanced civilizations actively avoid detection by potentially hostile neighbors. This hypothesis proposes that 3I/Atlas represents sophisticated camouflage technology designed to appear as a natural comet while actually conducting systematic reconnaissance of our solar system and Earth's technological capabilities. Dr. Seth Shostak from the SETI Institute acknowledges that, while this idea is speculative, stealth hypothesis explanations account for otherwise inexplicable observational patterns, better than conventional astronomical models. The perfect timing of its approach, strategic positioning during key observation windows, and minimal electromagnetic signature could all indicate advanced concealment protocols developed by civilizations with millions of years of technological evolution. If confirmed, these stealth capabilities would suggest that 3I/Atlas represents technology far beyond anything humans currently understand, potentially indicating that extraterrestrial surveillance of Earth has been ongoing for extended periods without our detection. The implications here extend well beyond simple scientific curiosity to fundamental questions about human security and our readiness for contact with advanced civilizations that may be studying us from the shadows. Now, critics argue that stealth hypothesis thinking promotes paranoid speculation rather than rigorous scientific analysis, But proponents note that dismissing possibilities just because they're unsettling is more emotional than logical reasoning. The debate continues to influence both scientific methodology and public policy discussions about how humanity should prepare for potential contact with extraterrestrial intelligence operating within our cosmic neighborhood. Lessons from Oumuamua. The scientific community's response to 3Y Atlas has been, in many ways, heavily influenced by the controversial handling of Oumuamua back in 2017, when humanity's first confirmed interstellar visitor was dismissed as merely unusual instead of potentially extraordinary. Dr. Avi Loeb argues that the astronomical establishment's rejection of artificial origin possibilities for Oumuamua represents a missed opportunity that really shouldn't be repeated with 3I Atlas. The earlier visitor's anomalous acceleration, extreme elongation and lack of outgassing were explained away through increasingly complex natural theories, rather than seriously investigating simpler artificial explanations. Today, our detection capabilities and analytical techniques are way more advanced than during Oumuamua's brief passage, providing unprecedented opportunities for detailed characterization of 3I Atlas before it disappears into interstellar space. The James Webb Space Telescope, advanced spectrometry and artificial intelligence analysis systems now offer tools that were unavailable or underdeveloped during our first interstellar visitor encounter. The lesson from Oumuamua is clear. It's important to investigate all possibilities, including extraordinary ones, rather than defaulting to conventional explanations that may not adequately address observed anomalies. 3I Atlas represents potentially humanity's second and possibly final chance to properly study an interstellar visitor during this generation, making thorough investigation crucial, no matter the initial skepticism. Scientists worldwide are coordinating unprecedented observational campaigns to ensure that this opportunity isn't wasted through premature conclusions or insufficient data collection. The stakes honestly couldn't be higher, since 3I Atlas may be our last chance for decades to determine whether we're alone in the universe or sharing it with advanced civilizations. The mystery of 3I Atlas continues to deepen with each new observation, challenging our understanding of what's possible in the cosmos. Whether it's an ancient comet with unusual properties or, something far more extraordinary remains hotly debated among scientists worldwide. What do you think about these strange findings? Could we be witnessing our first confirmed encounter with extraterrestrial technology? Share your thoughts in the comments below, and don't forget to subscribe to Sci and Y, and hit the notification bell for more mind-bending space mysteries. Keep questioning the universe.